Hi everyone, we are from PISMP Mathematics, intake June 2021 2026, class K1. And today we are excited to present our project, which is our Kppb Science 2025 titled An Innovative Master Plan for Advancing Science Education. Under the guidance of our lecturer, Dr. Khalida Ahmad, we've explored creative and practical strategies to elevate science education for young learners, make it more engaging, hands-on, hearts-on, and minds-on, and very meaningful. So, let's begin this journey together as we share our ideas, insights, and passion for teaching science. Okay, this course, SCS3404, is built on a powerful idea that science isn't just about memorizing facts or doing worksheets. It's about sparking curiosity, excitement, and wonder in young learners. Our goal is to ignite that spark by making science thrilling, hands on, minds on, hearts on, and full of surprises. We'll explore ways to make science come alive in the classroom. Okay, so to guide our journey, we'll focus on three essential questions. How can we make science engaging and meaningful? We'll explore techniques that grab students' attention and relate science to their everyday lives. Second question, how can we assess students' understanding effectively? We'll go beyond tests to discover authentic, practical assessment strategies. How can reflective writing and classroom assessment improve us as teachers? This is about growing professionally, using reflection to sharpen our instructional skills and become more effective educators. Okay, to answer those essential questions, we'll apply a variety of strategies and approaches. The first one, hands on learning and practical skills. So, through this, we let students touch, build, and experiment. Second, cross curricular connection. This can integrate science with math, language, art, and more. Third one, STEM integration. We promote critical thinking through technology and engineering projects. And lastly, problem solving. We encourage students to think like real scientists and tackle many challenges. So, these methods aim to make science more than just a subject, but a meaningful, engaging experience.
Okay, on this slide, we like to share how our activities align with the elements of 6C and essential 21st century skills that shape effective and holistic learning, which are the first one is critical thinking, creativity, collaboration, communication, citizenship, and the last one is character. Firstly, through the group work activity, we strengthen collaboration by working in teams to design a lesson plan. We practice communication by expressing our ideas clearly, listening to each other, and giving constructive feedback. This process also required critical thinking as we had to analyze curriculum standards, align them with engaging strategies, and justify our pedagogical choices. And our field trip to Yayasan Jacob was a valuable experience. In promoting citizenship, we saw firsthand how organizations contribute to environmental sustainability and community development. This gives us a deeper understanding of our roles as future education in raising public awareness and encouraging civic responsibility. Lastly, our reflection on the lesson plan help us develop our character. we became more aware of our strengths and weaknesses, took responsibility for our learning, and identified how to improve. The process also inspired creativity as we explored new ways to design meaningful science lessons that connect to real life issues. All of these experiences didn't just build our professional knowledge, they shaped us into responsible, forward thinking educators. Okay, moving on to the 3E framework, this model guided us in creating a more engaging and meaningful learning experience. The first E stands for engagement, which involves connecting science content to real world issues such as environmental awareness and sustainability. This helps make learning more relevant for students. Next is enhancement. We use interdisciplinary strategies and reflective teaching practices to deepen our understanding and reinforce scientific literacy. Hands-on activities and teacher reflections were crucial in this stage. The third one is extensions. Emphasize the application of knowledge in real-life situations by integrating STEM activities and project-based learning. We encourage deeper thinking and problem solving across different disciplines.
Okay, so today I will walk you through our 3R framework, which is the foundation for our teaching and learning strategy. First R stands for rigor. We apply problem solving and project based learning to promote high order thinking skills. We also use the backward design approach, which ensures every learning activity has a clear outcome and structure. Second R is relevance. Learning becomes more meaningful when it's connected to real life. That's why we adopt experience based learning and contextual learning, making science easier to relate to and more engaging for students. And the last R, the third R, is relationship. We believe that collaboration is the key. We, bel we work closely with science teachers, SISC Plus, and subject matter experts through professional learning communities (PLC). This enrich the entire learning experience for both teachers and students. We also build strong connection with learning partners to support our 3R framework. Two of our main collaborators are Yayasan Jacob and Zhu Johor. This partnership gives students the chance to explore science beyond the classroom. As part of our strategy, we conducted virtual interview with our partners to discuss how their expertise can be integrated into our learning lesson planning. This interview allowed us to explore effective teaching strategies, including project based learning and contextual application of scientific concepts. Technology plays a vital role in our teaching process. We integrate digital tools to enhance communication, context delivery, and assessment. First, we use Google Meet for live teaching, interactive discussion, and interview the subject expert matter. Second, Google Classroom. Google Classroom help us organize resources, assignment, and announcement in one place. And lastly, we conduct online assessment to track student progress effectively and provide timely feedback. Okay, so we move to the advantage of these courses. First, these courses make learning enjoyable and interactive, which fosters interest and enthusiasm among young learners. And second, these courses provide access to diverse resources, such as a book, experiment, online tools, and visual aids. This enabling students to grasp concepts in the multiple ways. And lastly, these courses are flexible and allow learning to happen in diverse settings, whether at the campus, home, or outdoors. This adaptability makes science education more inclusive and accessible.
While technology has greatly enhanced the educational experience, there are some challenges we should consider, especially when using tools like Google Meet, Google Classroom, and online assessment. One of the major challenges is time. Setting up and managing online platforms such as Google Meet and Google Classroom take time for both teachers and students. Teachers need to plan virtual lessons, manage digital assignments, and troubleshoot any technical issues. This can add to the workload and reduce the time available for face-to-face learning or other important activities. Another significant issue is internet connectivity. For tools like Google Meet to function smoothly, students need a stable internet connection. Slow and unreliable internet can disrupt online lessons, hinder students from accessing materials on Google Classroom, and cause frustrations during online assessment. Connectivity issues can also lead to delays or missed interactions, reducing the effectiveness of virtual learning environments. Now, let's reflect on the key things I have learned through exploring these frameworks and teaching methods. So first, I have learned the immense value of working with experts in the field. Collaborating with subject matter experts provides deeper insights into complex topics, which enhances the overall learning experience for students. It also helps to bridge the gap between theory and real-world applications, giving students a richer perspective on the subject matter. Besides, I have also learned how important it is to make the learning fun. So far learning strategies such as hands-on activities, interactive projects, they can help engage the students to make complex concepts more accessible. When students enjoy the learning process, they are more likely to retain the information and develop a lifelong love for the subject. So, another important lesson is the growing role of digital tools in education. So, using the digital resources effectively not only enhances the learning experiences, but also helps students build crucial digital literacy skills. These skills are not only essentials for their study, but are also important in their modern workplace. To measure the success of these frameworks and teaching strategies, we can consider the following criteria. One clear indicator of success is the field trip to Yayasan J-Code. This allows students to see how the concepts they are learning in the classroom apply in real-world settings. Such experiences help reinforce their understanding of the material and encourage them to think critically about its real-world relevance. Effective pedagogy is another key measure of success. Success in teaching is about more than just delivering content. It's about how well the method engages students, promote active learning, and foster critical thinking. While pedagogists support these goals, students are more likely to grasp concepts deeply and apply them in various contexts. Lastly, success can be measured by how much students enjoy the learning process. If students are excited, curious, and actively participating in the lessons, that is a sign that the learning experience is successful. So, fun learning fosters a positive environment where students feel comfortable exploring and experimenting with new ideas. That's all from us. Thank you for listening.